Hello everyone. Through nanotopography, the human body is getting closer to machines with biohacking actions. Using nanotechnology for mapping and cataloging with ID number the human choose parts as in the engineering machines. A study that uses nanotopography to approximate biology with mechanical engineering by the topographic, microfluidic and nervous mapping of Manchu is at the nanotechnological level, the bottom-up from top-down by the slicing and characterizations biologic tissues. How can I been talking tell so much about human tissues engineering? It was for these questions that as I research, began taking an alternative way beyond DNA sequences for understanding the tissues. When studying the differentiations in plants, totipotencies, protoplasts, meristematic tissues targeting a future investigations with the EPSCS, but beginning with the pluripotent vegetable cells was decided that to slice I've been stalking completely from its roots the leaves using a choose slicer. Soon after photocopying the cut parts to digitally reassembling and mapping the internal microfluidics as a template to be applied on the artificial tissues. The study named biomimetic and functioning artificial tissues, mastering irrigation, nourishment, microfluidic and nerve network to keep the cell alive. Exposes researches on nutrients, oxygen, and the other life support needed to keep it alive, specialized cells that make up the artificial tissues and organs. This research aims at a future collaborative works focused on the nourishment of cells in artificial tissues in the long work for mapping the tissues and standardizing the parts, besides identifying with a code the items of the tissues and processes for each circulatory and nervous system. The study also shows the potential that new sciences and technologies confer on the feasibility of new studies towards artificial life, which is related to the greater precision in the understanding of the world at the nanotopological and nanotopographic level, including process of the biological choice. Among the subjects and future perspectives to this research include cataloging vessels, microfluidic parts, and minimal process that to keep alive cells in tissues, mapping and code each circulation microcanal with an ID number linked to a datasheet, generating accurate data and information to feed new human artificial tissues process production machines, create cataloged information on biological spare parts with datasheets for specification and characterization, the traditional complex machines engineering and integrated circuits architecture techniques for microfluidic networks in human tissues. The future intention is to mapping the entire microfluidic and bioelectrical flora on human tissues and add ID number to each irrigation circuits, biological circuits for creating spare parts, several spare parts, similar to engineering made in integrated circuits architecture or in mechanics. Each circulation line flow or communication identified and calling its datasheet with all respective, all descriptive, technical specification and characterizations for mapping the cell structure and the matrix around. In the artificial tissues, their connections, works, and process that they do to stay alive. All for a better understanding of the connections, receptors, terminations, nutritions, communications, and fluidic transport on the detailed nanotopography. The nanotechnology and the technique is used in the traditional engineering for mapping the components of the human body and the documents the parts with an ID number to call a datasheet presents a huge potential for the bring together and it presents understanding from several specialists into on a single descriptive biological manual for all biological circuits. A technique similar to the performed in the mechanical engineering, used in aircraft, helicopters, vehicles, and complex machines, industrial machines in general, to have a general report, control and acknowledgement of the parts that make up the world. The major difficulty is not in the generation of the new tools with techniques, example using iPSCs induced pluripotent stem cells, but in the organization and tissue functionalizations. This is the point. When repairing two living cells on a tissue, the problem is to reconnect them in a perfect harmonic regeneration, keeping the networks of nutrition, electrical and structural communication intact, as well as making these connections recognized by the body. However, nanotopographic and engineering techniques alone may not be enough for a complete new choice mapping technology because of the complexity involved. The difference that surround nanotechnology and bioscience is defined not only by measures but also by effects. The effects, the events, methods, and dynamic processes. The process is the key. As presented in the recently published study entitled Biomimetic and Functioning Artificial Tissues Mastering Irrigation, Nourishment, Microfluidic, and Nerve Networks to Keep the Cells Alive. The study is suggestions for possible future perspectives with a precise code for the identification of the biological circuits on all fluid circulations and nutrition canals in the body, in the tissues. More precise studies and even standardizations, a pattern will be viable with this progress of this study. With these studies, the viability of artificial organs will become increasingly accurate and even new organ formats can become common, as already done in replacement parts of machines, cars, and airplanes. In general, engineering, mechanical engineers process, as well as the identification of damaged trees that required regenerations with an ID number for better understanding on each termination. So, this preliminary study attempts to bring more technique as engineering standardization for this new so small anthropometric science for trees in general and biological circuits comprehension as an alternative way for a new study on cyborgs, artificial life, and improved depths as soft lab-on-chip with a heavy use of the surface area on its network of microcanals at nanoscopic level. The nanotechnology works in the range on size from 1 to 100 nanometers. Biology and general bioscience go much further than dimensional ranges around micrometers, nanometers, fragments of parts around angstroms and moles, something rarely heard for works. Some biomolecules range around 216 nanometers, human cells around 25 100 micrometers, in addition to measurement of some virus near 115 nanometers. The human body parts are very varied. In fact, the discussion revolves around a new human anthropometry. The anthropometry by nanotechnology is a revolution in choice. This new anthropometry of the human biological choice components that don't have a pattern yet for a expected future manufacturing of the biological parts. In this new biological anthropometry involving micro nanoparticles, each necessary component must be considered.